Whether you dey sit for WAEC or you dey sit for NECO or you dey sit for GCE or NECO GCE or JAMB, you go see question wey dem go give you under harmonics. Dis question I go use am explain wetin harmonics be and why dis topic for physics dey very important. E say make you evaluate the frequency of the third harmonics of a closed pipe of length 0.3 meter. They give us the speed of sound in air to be 340 meter per seconds, and this na the option. This na JAMB question, but wetin you go learn for this class go help you understand harmonics very well, especially the harmonics wey dey for closed pipe and wey dey for open pipe. So this video go long small because I go do a lot of explanation. This na Unique Pidgin Academy, where we dey use pidgin to take teach una topics like this for all subjects so that una go fit understand am. So as you dey watch this, make you no forget to like this video, make you share am with your friend, and no forget to subscribe to my channel so that you go dey get most of this content when we don put am for our channel. Now, when we talk about vibration of air inside any pipe, e dey always produce sound. So when we see air, we get one space or any small pipe, and you dey one side of the pipe shout oh, you go see say the other person wey dey for the end go hear am, because waves go pass through that pipe reach the other person. I remember when we dey small, when we see small hole, we go put our mouth, we go shout for the small hole, and the other person go put im ear for the other place, he go hear wetin we talk. That one na waves of sound na im dey produce for inside that hole space. Now, harmonics dey always produce, it all depends on the kind of pipe. E fit be open pipe or e fit be closed pipe. Now, when we say pipe dey open, na pipe wey dey open for the end like this. Here dey open and here dey open. Now, when we talk of closed pipe, na pipe wey dey close like this for one end. Maybe say two of them dey close. Either say e dey close for here or e dey close for here. That means say one side of the pipe dey close and one side dey open. Now, when sound pass through any pipe, when air go vibrate inside that pipe, and that air wey vibrate inside that pipe go produce wetin we dey call longitudinal or stationary wave along the length of that pipe. Now, when we consider the wave of that pipe, the kind of frequency or the kind of wave, the length of the wave wey go produce, e go depend whether na open pipe or whether na for closed pipe. Now, make we first consider the issue of closed pipe. Later, we go talk about open pipe. So we want talk more about closed pipe. Remember, I tell you say when we say a pipe dey closed, the pipe dey closed for either one of the end, either for the up or for the down. And this question wey dem give us na question under closed pipe. So how we go take handle this closed pipe? Now, when air pass through or sound go through any of this closed pipe, remember say e dey close at one end, and because e dey close at one end, when the sound enter, e go hit here and e go go back. So this place na node. Remember, for wave we had node and we get antinode. The antinode will occur at the end of the weighting of the pipe, the maximum altitude of that pipe. Now, if the sound come here, it will come like this, sound of wave. It will come like this, sound of wave. Remember, this now wetin we dey call wavelength. So the distance between the node and the consecutive antinode, now wetin we dey call the wave form, or we call am the wavelength. And remember say the distance from one node to one antinode, we dey call am wetin? We dey call am a wavelength. And wavelength dey equal to lambda. The wavelength, we take am as L, dey equal to lambda divided by 4. So that means if this one go like this, come complete one node, for this antinode, here na antinode, here na node, that means e don make one complete what? Wavelength. And that means we will get half lambda divided by 4 plus lambda divided by 4. So that means one complete wavelength na wetin? Na half, or 1 divided by 2, because if you add this one now and simplify this one, you go see say you will get lambda divided by 2. So our length, our lambda go dey equal to 2 times the length. That one, we will talk about that one when we enter closed pipe. But this one now, wetin I want you to understand for close, or when we talk about open pipe, but wetin I want you to understand for closed pipe is say the wave no dey complete, because here you go only get this one, and the next one wey you go see, because of the maximum altitude, because here dey open, na here you go see the another antinode, and the other antinode fit dey like this. Here go become the antinode, the last point. So in every closed pipe, the length of the wavelength na always lambda divided by 4. Make you take note of that one, e dey very important. So if we make lambda subject of the formula, that means the full lambda or wavelength na 4 times the wetin? Times the length. Take note of this one, and this one dey always happen for wetin? For closed pipe. So there is wetin we call the fundamental frequency. Now under length, remember say frequency dey equal to the velocity of any wavelength is equal to the frequency is equal to the velocity is equal to f what? F lambda. The velocity of every wave is equal to f wetin? Lambda. So we fit find the frequency. The frequency na velocity divided by lambda. Take note of that one. This na fundamental formula for wave for physics. So we get velocity, frequency times the lambda. So that means the frequency go be velocity times the lambda. Now if lambda na 4 times length, so that means the frequency of sound inside this pipe could dey equal to the velocity divided by the 4 length. And this na the frequency wey the first frequency for this pipe, and the first frequency for any pipe we dey call am the fundamental wetin? The fundamental frequency. So in case they ask you make you calculate the fundamental frequency na f naught, na im be the fundamental frequency. Now the next frequency, this fundamental frequency, na which time e dey happen? E dey always happen when the lambda or the length dey equal to what? Lambda divided by 4. I know say you dey understand this. So if you get that one, you go know say this one, other ones go dey very easy. Now if this one na the fundamental frequency, that means na the first frequency wey we dey get inside a closed pipe. So wetin go be the next frequency? Now the next frequency, remember say this one go close, and then we don get one full length, and one full length go be lambda. Here go become lambda divided by 2. And when that one close, a full length will enter, because we just get one part. So this one will become antinode. So we don't get one full lambda and what? And lambda divided by 4. So we don't get one full lambda divided by 2, and lambda divided by 4. So that means for the second frequency, for we to get to the antinode, because no matter how it be, since na open pipe, we go always get antinode at the end. Now it be the maximum altitude. I don't know whether you get am. We will always get antinode for the end. So if you add this one now, you go find out, say, for the next frequency, our length will be equal to lambda divided by 4 plus lambda divided by 2. We will get lambda divided by 4 plus lambda divided by 2. If you do this one will give us 4. 4 divided by 4 will give us 1. 1 times lambda will give us lambda, plus 4 divided by 2 will give us 2. 2 times lambda will give us 2 lambda. So that means this one will give us 3 lambda divided by 4. So that means the length for the second frequency will be 3 lambda divided by 4. With this now, we go fit find our lambda. Our lambda will be 3 lambda. Our wavelength could be 3 lambda times 4 length. So our lambda will be equal to 4 length divided by 3 3. So with this now, we will fit get wetin the second frequency will be. Remember, second frequency will become F1, and F1 will be equal to velocity divided by lambda. And wetin be lambda? The lambda na 4L. So our F1 will be equal to velocity divided by 4L divided by 3. So that means our next frequency will come out at what? At 3V divided by 4 length, because this one will come up. So this na the next the next frequency. So if our first frequency will come out at V divided by 4L, second frequency F1 will come out for 3V divided by 4L. Now with this note now, you go fit note wetin the third frequency will come out from. Wetin you think say go be the third frequency? Now the third frequency will come out like this. Make you see the third frequency. Remember, say you go add another wavelength. So this one will complete, then we will add another wavelength, because it must end with wetin? It must end with antinode. So if this one na half, this one will become half, and then we will get 1 divided by 4. So this one will become lambda divided by 4. So we get lambda divided by 4 plus lambda divided by 4 plus lambda divided by 2 plus lambda divided by 2. Wetin that one will give us? That one will give us 5, or lambda. It will give our lambda, because it will give us our length. It will give us our length to be equal to, just as we find that one, our length will be equal to, the length will be equal to 5 lambda divided by 4, because if you do the LCM of all these things, you will get them 5, because this one will give us 2 plus 2, that is 4 plus 1, 5 divided by 4. So that means our lambda will be equal to waiting. Our lambda will be equal to 4, will be equal to 5, just as we get this one, 5. If we make lambda subject of formula, 5 will be equal to 4L. So our lambda will be equal to 4L divided by 5. So with this lambda now, we go be able to do waiting. We will be able to find the next frequency, because the next frequency will be frequency F waiting, F2. And F2 will be V divided by lambda. So V divided by 4 length times 5. So that means our F2 will be equal to 5V divided by 4L. That's our what? That's our second frequency. 5V divided by 4L. So you see now, this one now wetin we dey call the first overtone. This one na the fundamental frequency, or we call am the first overtone. This one na the second overtone. This na the third overtone. And remember, they say the third overtone. If this one na fundamental frequency, this one could be the first overtone, then this one will be the weight, the third overtone. So this go dey like, this one go dey like 3 of the frequency. If this one na F of the frequency, this could dey 3 of the frequency, and this could dey wetin 5 of the fundamental weighting frequency, because fundamental frequency na weighting na V divided by 4L. So you see, like so the overtone go dey go. So which one come be the harmonics, the third harmonics? Na this one be the third harmonics. We dey call am the third harmonics, or we dey call am the first what? Overtone. Because na there we get the first what? The first overtone after this one. This one complete am, then we get the first overtone wey be this one. So it's either we call it the first, we dey call am the first overtone, we dey call am the second overtone, the first overtone, or we call am the third what? The third harmonics. So how we go take calculate that question now wey dem give us, na im be the main thing. That means say that question wey dem give us, na this formula we go take calculate am. But before we calculate am, make I just tell you some few things about open pipe. For you now to don understand close pipe, make we talk about open pipe. Now remember, I tell you say open pipe na pipe wey dey open for the two places. E dey open for up and e dey open for down. Na wetin we dey call open pipe. Now if a pipe dey open for up and down, that means say the up and the down na dem be the maximum altitude, and na there go get the antinode and the antinode. That means say for any open pipe, we dey always get antinode here, and we will always get wetin? Antinode here. So make you dey always take note of that one. So that means the first fundamental frequency, or the first fundamental frequency, or the first harmonics, we call am the first fundamental frequency, or we call am the first harmonics. This na the first overtone. This na the second overtone. This na the second overtone, this na the first overtone, and this na the fundamental frequency. Make you take note of this one. E dey very important, because many students dey confuse for this one. Na im make I dey point am. This na wetin we dey call the first overtone, and na im be the third harmonics, 3F. This na the second overtone, but we dey call am the fifth harmonics. Make you take note of this point. This na wetin we dey call the fundamental frequency. Nothing concern am here. So third harmonics, fifth harmonics, the next one we go get na the wetin? The seventh harmonics. Now you see how that one go. Now make we see how close pipe go be. Now since close pipe dey like this, that means say we go get wetin? We will get for the first length, we will get one half wavelength, and this one waiting half wavelength. So here go become the waiting, the node. So remember say this one no form one full wavelength. This now lambda divided by 4. This now lambda divided by 4. So that means all of this one will be waiting lambda divided by 2. So how we will take get our first fundamental frequency, or wetin we go call the fundamental frequency, na im be the first frequency wey we go get. So for us to get the first frequency, remember say our length must dey equal to this dey equal to the length. So our length, our lambda must be equal to 2 times the weighting times the length. And you remember say frequency, which is f naught, is equal to v divided by lambda. So lambda, this fundamental frequency go dey 2 divided by 2 weighting, 2L. So this na im be the fundamental weighting frequency. So in any open pipe, they say make you calculate the fundamental frequency. This na the fundamental frequency. The next one wey dem go ask you make you calculate na the first overtone, or for open pipe we call am the second harmonics. After that, we get the third harmonics, we get the fourth harmonics. Now open pipe arrange themselves, but for closed pipe we get first overtone, we get second overtone, we get second overtone wey be the fifth harmonics. So make you take note of this one. Now the next one now for closed pipe na something wey go dey like this. Remember, the antinode will always dey at the end. So if one antinode come here, this wavelength will come dey complete. Then we will get another weighting, we will get another antinode, we will get another half wavelength there. So if you check this wavelength, we will get this one to be lambda divided by 4, this one will be lambda divided by 2 complete wavelength, and lambda divided by 4. So for the first harmonic, if you add all these ones, you go see say our lambda, all these ones will just give us lambda, and the lambda dey equal to length. So nothing change. If you add all these things, you will see say all of them, this one na 4, 4 divided by 4 na 1, 1 plus this one, 1 plus 2 na 3, plus 1, 4, 4 divided by 4 na 1, so it will give you lambda. So if that one will give you lambda, then our f1 go dey equal to v divided by lambda, and lambda dey equal to length. So weighting that one tell us that this one is the second weighting, the second frequency, the first overtone or second harmonics. So take note of this. This is the first overtone, this is the fundamental frequency, this is the first overtone or second harmonics. The next one we will get now our lambda. If we add another one, remember these two will come, this one will dey complete now, this one will dey complete now, and another overtone will come up. You don't see am? So this one will be weighting, this one will be half, and this one will be lambda divided by 4. So you don't see how we dey take do am now. The next one now, this one will dey complete, then we'll get another one up, because that antinode at the maximum altitude, and it will always be open at both ends for open pipe. So if you add this one, add this one, add this one, add this one, our next harmonics, our lambda will be equal to, if you add this one will give us what? 3 lambda divided by 2. And wetin the length will give us. So if the length give us 3 lambda divided by 2, then our 3 lambda will be equal to 2 length. So now wetin be our lambda? Our lambda will be equal to 2 lengths divided by 3. So if lambda dey equal to 2 lengths divided by 3, the next thing we will find now in our next harmonics, which is the second harmonics, the second overtone, F2, will be equal to lambda voltage, velocity divided by 2 length divided by 3, and this one will give us wetin 3v divided by 2 length, and this na 3fo, that is the third harmonics, and na im go be the second overtone. Fundamental frequency, first overtone, second harmonics, second overtone, the third harmonics. Now the next one we go get now na third overtone, and it will be wetin, it will be our fourth harmonics. So you see how the whole thing dey go, and this one na how you go take get your fundamental frequencies, your frequency for open pipe. Now let's answer, go answer the question. With all these things now, I know say you don't understand wetin open pipe mean and wetin closed pipe be, and how you go fit take get all your harmonics or the overtone from this pipe. Now the question say make we evaluate the frequency of the third harmonics of a closed pipe of length 0.3 meter. The first question, I would think what they tell is make you do now, ask yourself wetin they give you. One, they give us the length and they say the length now wetin 0.3 meter. Now wetin they give us again, they give us the velocity of sound in air. The velocity na 340 meter per second. Now wetin they give us again, they tell us say na closed pipe, and they ask us make we find the frequency. So where your mind go now be say, they say na third harmonics for closed pipe. Remember, closed pipe get the fundamental frequency. After the fundamental frequency, it gets the first overtone, and that first overtone na be the third harmonics. After that first overtone, it gets the fifth harmonics, and that fifth harmonics na be the second overtone. So making these things no confuse you at all. We get harmonics, we get overtone. So just make sure say you know this one. This na fundamental frequency, this na first overtone, and na be the third harmonics. This na second overtone, and na be the fifth harmonics. So they fit ask you make you find the fifth harmonics. So the third harmonics na wetin, na our f1 frequency, na f1 divided by 3 times velocity divided by 4 times the length. So the frequency for the third harmonics would be equal to 3 multiplied by 340 meter per second divided by 4 times 0.3 meters. So if you calculate that one now, this one will give you 3 times 340. That one will give you equal to 3 times 0 na 0, 3 times 4 na 12. You write 2, carry 1. 3 times 3 na 9 plus 1, 10. That one will give you 10 meter per second. Meter per second. This one are divided by 1, so it will be times 1 divided by m. This one will cut this one. So wetin we will get now, this divided by 4 times 0.3 will give us 1.2. So our frequency now will be equal to, remember say the frequency they measure them in hertz. So if you calculate this one now, you go find out say your answer will be 850 hertz. So that means our third harmonics will be equal to the first overtone would be equal to 850 hertz. And that one na be the answer. If you check the option, you will see say the right answer na answer option waiting, option B. So you see, question under harmonics, whether it come out for your JAMB, come out for your WAEC, or come out for your NECO, whether private or public, GCE, go, or the one wey they take for school, SSCE, go take this pattern to take answer this question. So if you don't watch this video, go check a lot of questions and see how the question be. That one will help you understand harmonics very well, so that anytime wey they ask you question under harmonics, you no go find them hard, you go just get the answer. If you really like this video or this class and you enjoy am, make you give this video a thumbs up, and make you no forget to share this video with your friends wey no understand harmonics for physics. And as you do that, make you no forget to subscribe to our channel, because na this channel we dey use teach una correct subject, or una subject for the language wey una dey understand. If you enjoy this class, make you no forget to join us for our next class, as we will take some other subject for pidgin. Una, thank you so much for watching, and I will see una next time.